In the 1960s, Teflon was coated onto cookware and revolutionized the way the world cleans up. But move over Teflon, you got nothing on the lotus plant. When a drop of water lands on the surface of the plant's leaf, it rolls right off, and with it goes any dust particles it encounters. University of Rochester professor Shaila Guo used the lotus plant as inspiration to create a myriad of new technologies. Among them is superhydrophobicity, and it is achieved with an extraordinary laser. Femtosecond laser surface treatment is a revolutionary technology that creates a complex pattern of micro and nanoscale structures that gives metals water repellent and superhydrophobic properties. Sci-Fi News on January 21st, 2015 tells us that this material is slicker than Teflon. For example, a Teflon-coated pan can prevent food from sticking, but the superhydrophobic material can be the cookware itself. Most importantly, the International Business Times on January 21st, 2015 states that this technology can also benefit third world countries, where rainwater collection is vital, and the use of superhydrophobic materials can increase the efficiency and cleanliness of this necessity. In order to get a hold of this revolutionary process, let's first look at what femtosecond laser treatment is. Second, explore the future applications of this new laser technology. And finally, discuss the challenges that must be overcome in order to make these applications a reality. Let's begin by learning about the properties of superhydrophobic surfaces, and then how it's created by using femtosecond laser technology. So, what is a superhydrophobic surface? Professor Guo's study published in the Journal of Applied Physics, Winter 2015, shows that when a drop of water is released and falls towards a treated surface, it is repelled to such a degree that it bounces off the surface, lands again due to gravity, and bounces off the treated surface area. Any drop sitting on the surface will slide away. Professor Gould claims that such surfaces have desirable functionalities such as anti-corrosion, anti-icing, anti-biofouling, antimicrobial, low flow resistance, and platelet anti-adhesion. Sputnik International on January 24th, 2015 states that as the water bounces off the treated surface, it will pick up and carry away any dust, a theory tested by covering the surface with dust from a vacuum cleaner bag. 3 drops of water picked up half the dust particles. The surface was completely clean after just 12 drops of water, leaving it both dry and dust-free. Further, many of the hydrophobic materials that exist today, like Teflon, need a 70-degree angle in order for water to slide. But Dr. Guo's surface only needs 4 degrees or less for the same results. But how is this magical surface created? The Economist on January 21st, 2015 explains this process. Lasers deliver the energy at a rate of a femtosecond, a millionth of a billionth of a second. These pulses are so rapid, there is no time for the material to heat up, which creates a nanometer scale bumps and valleys where the material was, creating a self-cleaning, water-repellent surface. Researchers from Boston University on July 17, 2014 states that the surfaces have a texture that may appear smooth to the naked eye, but is microscopically rough with atom-sized pits, spikes, and pores. This microscopic texture traps air in these pits, so any water droplet only touches a fraction of the solid surface. Professor Guo used a 1-inch metal surface made up of platinum, titanium, and brass. But CNN on January 22, 2015 affirmed that this method can be applied to other materials such as semiconductors and glass. Additionally, the Huffington Post on January 22, 2015 states that, unlike Teflon, we don't have to worry about coatings peeling off or the surface degrading over time. With a better understanding of what femtosecond laser treatment is and its properties, and how such a phenomenon is created, let's take a look at future future applications of this new laser technology in the areas of everyday objects, sanitation, and energy. The great thing about this new discovery is that it opens doors to many renovations. We can alter objects in our everyday lives to make them better and of higher quality. Tech Times on January 22nd, 2015 tells us that with such treatments, we can help protect most of our country's infrastructure. Currently, time, energy, and money is spent cleaning, protecting, and replacing things like power transmission lines and radar, or telecommunication antennas. But with the treated surfaces, we could be saving millions of dollars a year. Further, it has been of great interest to take this technology to remote areas. EE News Service on January 21st, 2015 states that with such treatments, better devices can be built to collect rainwater in developing countries. Second, one of the major benefits of this treated surface is of its self-cleaning property. It has been of great interest to use this treated surfaces to create more eco-friendly and antibacterial bathrooms. The University of Rochester on January 20, 2015 states that super hydrophobic surfaces can help build bathrooms that are healthier and cleaner to use. Washrooms are a challenge to keep clean in places with little water. If the surfaces of these bathrooms were made of super hydrophobic and therefore self-cleaning properties, your bathroom can be the cleanest place in your home. But I still wouldn't recommend eating dinner there. Last, the European Physics Journal on February 10, 2014 states that can you not be filming? That with this treatment, more efficient solar panels can be created. Physics Central on January 22nd, 2015 states that Physics Central on January 22nd, 2015 states that hold on. Okay. That the black appearance of a femtosecond laser treatment is directly